You can go from there. We could do 4 blocks, right? I was thinking maybe I could make it n blocks. Can you solve it with n blocks?
It just doesn't move.
It just doesn't move. We'll take the limit as n goes to infinity, holding the mass of each block infinitesimally, like constant in an appropriate way. No? Yeah. You have infinitely many blocks, but still a finite mass.
Yeah.
Because that's, you don't want to let the mass go to infinity. That's not good. Any questions about anything particular in the missions? We got some time. Yep.
I'm probably not alone in this. Could you go over some basic projectile problems that we'll just see and how to, like the general strategies of solving them, like which equations to use?
So a projectile motion problem.
Or like, just several templates, so to speak, of which ones we use.
Yeah.
So, I mean, ultimately the answer is you should do calculus. In the sense that all of the formulas we have derived for kinematics have been from, applying calculus. So, for example, the constant acceleration problem, basically we start with the acceleration is, 0 minus g is a vector, and then we integrate again, and from that we get these kinematic formulas, right? Trying to find something here. I'll find it. Give me a second. Oh, the three-body push problem was actually in the lecture notes, which you should be looking at. Yes. Let's see here. I think lecture 6 has some examples that we have not exploited yet. This is the basic thing is if your acceleration is minus gj hat, then when you integrate once you get this, and you integrate twice you get that. But these are vector equations. What do they mean at the level of scalars? It means that you've got constant velocity motion for x, and you've got this accelerated motion for y. But then when we actually do projectile motions, typically the v naught x and the v naught y are given in terms of the angle at which the bullet is shot, right? So the v naught x becomes v naught cosine theta, the v naught y becomes v naught sine theta, where theta is the angle of inclination for the bullet being shot. But I would say it's important to know the constant acceleration formulas. And it's also important to know that they're constant acceleration formulas, right? So if I ask you a question about, say, finding the position when the acceleration is like t cubed plus 3 or something, if the acceleration is t cubed plus 3, you can't find position from using the constant acceleration formulas because the acceleration is not constant, right? The derivative of the acceleration is 2t in that case I just talked about. So what do you do? Well, if the acceleration is t squared plus 3, you have to use calculus. This is calculus-based physics. That will happen on the test. There will be calculus on the test. There will be a problem on the test where you can't just pull a formula off your shelf and apply it. You have to think through it. Like that's part of this course. Yeah. You may bring a 3x5 note card to the test. Yes, I think I said that somewhere. Yeah. And you can only write on 2 sides of the note card. I should make sure that's clear. I once had somebody write on 4 sides because they pulled it apart, wrote on the inside ply. So yeah, don't waste your time doing that. Just 2 sides. Yeah. Handwritten, or it has to be written in blood of a friend. No, I don't know. I mean, you could print it. You could. I mean, if you want to bring a wood carving, like a 3x5 inch wood carving, and like wood carve it, carving. I'll accept carvings. Wood burning, perhaps. I do that. If you want to etch the equations in acid into glass and make it real ornate, I give you 10 bonus points. So no, I retract that. Someone was going to waste the time to do that. Yeah.
Is there a limit on the width of the 3 by 5 grid?
3 inches by 5 inches, as is commonly understood. 3 inches by 5 inches.
Oh, thickness.
Yes, it has to be at most 1 millimeter, let's say. Millimeter's not much. Okay, so what I was saying is a second ago, Sam, was that those equations we were looking at become these equations when you put in, you know, the angle dependence of the v naught x and the v naught y, of course. The equations I find myself using a fair amount are like the range equation, the max range. Keep in mind what that's for, though. Initial and final height being the same for the projectile motion, right? The max height formula sometimes comes up, but you should also be able to derive these equations, right? So understanding how to derive the max range equation, understanding how to derive the max height equation, those are kind of good metrics for whether or not you should have ownership of those equations. They shouldn't just be something you use blindly, you know? The other thing to be aware of in terms of constant acceleration motion is that we have tools that sometimes have to be used. Like on mission 3, if I remember right, there's a problem. Where did that thing go? Ah! Where'd you go? See if I can find that thing. Do you guys like the tent pole problem? No? So will there be a 3-dimensional problem on your test? I think yes, there will be, right? Well, you have to find the angle between vectors in 3 dimensions. That almost certainly will happen. The fact that didn't happen on the test we were just looking at is probably an artifact of me being sick of testing on it that particular year. I get demoralized sometimes and I just give up on a topic on occasions. I should give up on it? No. My will is strong. The angles will be on the test. Let's see here. Come on. Where'd you go? Where's that problem? Am I thinking of mission 2? What's the problem where we needed the average? We needed oh, I think that was here. I just missed it. This one. This one's tricky, right? This one was tricky. What? Seriously? Okay. Whatever. Okay, so the thing I used to solve this, and you might not have, I think I've seen a solution that doesn't use this, but one way to solve this was to notice that this is constant acceleration motion, right? Which means that the average velocity is the average of velocities. Let me repeat that. The average velocity is the average of the velocities. Do you understand the difference? So average, like 2 numbers, what's the average of 13 and 20? 13 plus 20 divided by 2, right? That's the average. So the average of the initial and final velocities, that's that. But on the other hand, distance traveled divided by total time, that's the average velocity, right? So the fact that these two things are equal means that VF has to be twice the average velocity in this case because it started from 0. And so that was important because then that, oh, I oughta. Nope. Try kicking it. Okay, great. It well could be my computer and, you know, see this up here? I didn't put those there. This has a / key, which is no longer functional. And some of you have gotten emails from me where I put in parenthetical comments, I'd like to put a question mark here, but I can't because I don't currently have a functioning question mark key on this computer. So I need to fix it, yes.
You can use alt codes in the number pad.
Do what?
You can use codes on your number pad and alt code to make certain characters.
Alt? But how can I make it not take this as an input? That's what I want. What's that?
I mean, put a question mark on it.
Oh, for the question mark button. Well, anyway. Thank you. I asked Dr. Wang, can I disable the keyboard? He's like, no. But you can repurpose keys, like you're telling me. But anyway, its time is gone. I need a new computer. So listen, so in this one, what I was getting at is for a constant acceleration motion, be also aware, if you're not interested in time, the timeless equation is sometimes helpful, like this. Vf squared is v naught squared plus 2a, times the displacement. Well, what acceleration is this? Well, that matters as well. It's the acceleration parallel to the plane, right? So anyway, that's all I'm saying is there's a grab bag of special formulas for the constant acceleration case. The average velocity is the average of the velocities is one of them. The timeless equation is another, So the max range, the max height formula. But generally speaking, you just got to work them out. If I can find another one. What did my test look like from 2013? Want to see? Here we go. I bet it looks similar. Ooh. A ball is hit at 30 meters per second. And let's see here. Oh, man. Come on. Oh, you have a question? Or no? That was not a question, that was a comment. Well, I would like to resize this, but there we go. Just trying to use the unusable keys. So I give the speed, the angle, and then I ask a bunch of questions like how far does it go horizontally, the max height, does it clear a tree a certain place? Yeah. So this is a good question. Here's this, as you can see, I like this question. It tells me a lot about what students do or don't know. No friction in that one. Mass hanging. Oh, rocket boots. A man with rocket boots produces a thrust twice his weight. He turns his boots on at an angle of 45 degrees from the horizontal for 3 seconds. Whoosh. And then he fires them for 3 seconds. How high does the man fly? That one's fun. So what I had to do there was to figure out his acceleration and then do the calculus. And then, so that's like a two-step thing. It'll give me the final velocity after the 3 seconds, and then that gives you a v0 x and a v0 y, which then you can sort through to find the maximum height and such. So, ooh, a regular tetrahedron is formed by joining 4 equal triangles, blah, 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 blah. Find the angle between the line connecting the highest point of the tetrahedron and the z-axis. Yeah, nobody got that right. That was a bonus question. I don't think anybody got that right. Well, anyway. This seems to be scanned in like the backwards order or something. Oh, I think we're looking at the end of the test rather than the start. Here's the start of the test. You got 3 points. Calculate the interior angle of the triangle PQR at Q. So, listen, as I make the test, I look at your missions, okay? And I don't mean what you did, I mean what I assigned, all right? So, I've posted solutions for all 3. I do hope that you'll, absorb them. Sorry, I've gone a minute over. I will shut up. See you.